Howdy, AP PreCal. It's Ms. Kosh. We are continuing with transformations of trig functions. So we started with, I'm putting 3, 6, 3, 8, and 3, 11 together. So I have taken a day to introduce the idea of periodic. I've taken a day to do the at this point, we know all 6 parent functions. So now we're continuing. I think this officially puts us into 3, 8. So it's kind of finishing 3, 8. So we're going to do the transformations here with 3, 8, and 3, 11, and just do all of transformations on all 6 trig parent functions. Super. Okay, so on this one, we know that this -1 is going to shift our graph down. So it won't change it. We have asymptotes, which I would want you to draw in clearly. And we've taken this graph and we've just shifted it down. So now we're doing something like this. We're down 1 and we've done something like this. So I want to see that you're concave down on one side, concave up on the other, and life is good. Describe shifted down 1. Super. Okay, on this one, now what are we doing? Well, we're moving it to the right pi/4. And so then this tells us that this guy is going to move to right pi/4. Our asymptote is going to move to right pi/4. And this one's going to move, so from negative pi/2 to negative pi/4. And so we're going to do something like this. I would ask, and then this guy does something like that. I would expect you to tell me the asymptotes. So on this previous one, we would say that the asymptotes are when x is equal to pi/2, is this one right here. And how far apart are they? They are pi k apart. And technically, we need to say kes, where k is an element of the integers. On this one, it's but we can see that they shifted, so it's either negative pi/4 plus pi k or 3 pi/4 plus pi k. I would take either one. But one thing that you can do is we can take this equation. You know what? Let me do it this way. Okay, if I have this equation, I know I'm going to switch it to x for a second, and you'll see why, perhaps, in a second. I know that the asymptotes of the parent function are when x is equal to pi/2 plus pi k. That's what happened here. We shifted it down, but it didn't change the asymptotes. These are the asymptotes of the parent function of tangent. If I take this and I replace the x is equal to with whatever affects the asymptotes. So a stretch out front won't affect the asymptote. A shift up or down out here won't affect the asymptotes. But changing the period and shifting left or right will. So if I change this and I say x minus pi/4, that's a 4, pretend. Wow, that's a terrible 4, is equal to pi/2 plus pi k. This is a systematic way to figure out where the new asymptotes are. I can add pi/4 to both sides, and I get that x is equal to, well, pi/2 plus pi/4 is 3 pi/4 plus pi k. Now, this one was pretty straightforward because we saw that in the graph, but they're not always this straightforward, or at least I have written problems that are not this straightforward. So x is equal to 3 pi/4 plus pi k are my asymptotes. I'm going to require that you write kes once per page, maybe. I don't know. I mean, officially, we should write it every time. Describe the horizontal translation phase shift. It's a phase shift of pi/4 to the right. Okay, the next one, now this one is going to affect our period. And so if you remember, we talked in the last video that it's the parent function period divided by b. So, but our parent function here is now pi. So this is pi over 1/2. Or you could think of this as pi divided by 1/2, which is pi times 2. So 2 pi is our new period. So that means our asymptotes, everybody's going to be stretched away by a factor of 2. So where we used to have an asymptote at pi at over 2, we now have an asymptote at pi. And where we used to have one at a negative pi/2, we now have one at pi. And so this new period, this one period is going to do, everything kind of gets pulled apart. And so it's doing something like this. Okay, I prefer graphing trig functions, just giving you blank space, because I want to see you set your own scale. This looks a little confusing, to be honest with you, but who knows what AP is going to want you to do. Describe the horizontal dilation. It's a horizontal dilation by a factor of 2. State the period. The period we just said was 2 pi. And then I want you to tell me where the asymptotes are. And so now it's x is equal to, this first one was here at pi. plus how far apart are they? They are 2 pi apart, so it's plus 2 pi k. Let me show you what I was talking about a second ago. If we take this, we know that x usually is pi over 2 plus pi k, but now we have 1/2 x is equal to pi over 2 plus pi k. What I can do to solve for x is to multiply everybody by 2, which means that this becomes x, this gets multiplied, it becomes pi, this gets multiplied, it becomes 2 pi k. And that's another way to think through and get that asymptote. Okay, phase shift right of pi over 8. So we have theta to go right, we have to do minus pi over 8. And then a vertical dilation by a factor that's pulling it this way. So we can just write tangent and we'll vertical back. So f of theta is equal to that. Oh, they said g. Oh, whatever. Don't care. There you go. That's sloppy, but I think you get it. Okay, we'll do secant and cosecant, cotangent. We'll do those in the next video.